My name is Brandy. I'm gonna go ahead and share my screen. So, hello, my name is Brandy. We're gonna do a very quick intro to Unity, specifically focusing on C Sharp. Bit about me. So I work for Leaftail Labs in Fremont, Seattle. We are currently working on a mobile augmented reality pet simulator that takes inspiration from Tamagotchi, Neopets, and The Sims. It uses AR real-time rendering and machine learning-based object detection. And it's actually built using Unity. So if you want to know more about us, follow us on Twitter. All right. Very brief overview of the topics that I'm going to cover in a very short time span. So I apologize in advance. I am going to be going pretty quickly here. So I'm going to try and get to all of these.
Real
First one
quick,
being introduction to Unity.
sorry, what was the name of that? Because I actually do want to follow you on Twitter.
Yes. Sorry. Niblity. Nibblity. And you can actually see those are some of our niblins. They are very, very cute. All of them are animals mixed with food. Good question. All right. All right. I will turn off.
There we go.
Can you guys hear me?
Yep.
Yes.
Okay, cool. Yeah, Unity just decided that it needed to die. All right. So, brief overview of today's topics. Quick introduction to Unity Engine. Components. What are they? Objects in Unity versus objects in object-oriented languages. Life cycle of objects in Unity. Making your first C# script. Using the C# to access components on other objects or on the same object. And then the last thing that I'll cover is just really quick tips for organizing things for your teammates. Some assumptions that I am making about you if you are in this workshop. You are familiar with at least one coding language. So if you are not, I apologize in advance, and you can grab me after this and I can go a lot slower for you. I am assuming also that you have not used Unity 3D before. So if you have used Unity 3D before, some of the things that I might be going over, you'll be like, oh my God, duh. Also, the last thing is that I'm assuming you are not trying to memorize what I am saying, rather that I'm just giving you a general overview and some things to keep in mind. So, last bit of I guess advice before I get started in Unity is read the documentation. Seriously, the Unity documentation is actually really good and has a lot of tutorials on it. One thing to note is that whenever you try to use a function, if you're pretty sure it exists in C#, check to see if it exists in Unity first, because if some function exists in Unity and separately in C#, Unity tends to prefer using its own and might bug out. So if you're looking anything up because you're like, I'm sure that this should exist in C#, look it up with Unity first. All right, and now having said that, moving over to Unity. Can everybody still see my screen?
Yep.
Yes.
Cool. So this is Unity. I just opened up sample project. Not going to go over that. This is my project view. I'm using dark mode because dab. This is my inspector. So the inspector over here is where I can click on any object in this hierarchy over on the left-hand side here. And boom, now I can see the super user-friendly version of all of the code that's over here. I can actually have several different inspectors here, and the reason why I have several different inspectors is that if you look over on the very far right here, there's a tiny little lock button. So I can actually press this and say, hey, I really want to keep an eye on the camera, but I have to select other objects, and also I want to look at them too. So whatever you have the lock icon on, it will stay hooked on that object so that I can go in between and be like, oh, okay, cool. So you can also make other windows appear here. There's a debug option so that you have more options that you can look at. I've never really used it. You can have more tabs open. All of these you can pull them and you can put them here, you can put them here, you can do whatever you want with them. Unity does try to make it pretty flexible like that. So like I mentioned earlier, over on the left-hand side here, we have all of the objects that are currently in your scene. So I'm going to go ahead and just drop a cube in there. And you can see now that I've got my cube, it's appeared in the hierarchy, and I can see over here all of the code that is currently on the cube that automatically comes with the cube. All of these buttons up here are really nice, quick references. So hand tool, the ones that I use the most are going to be this transform tool, which is going to move things around, and the scale tool, so that I can go ahead and make it as big as I want, like this. Cool. Or the rotate tool. So I'm going to go ahead and rotate. And then I just want it to go back to 0, 0, 0. So you can also see the options here for position at X, Y, and Z, rotation X, Y, and Z, and scale X, Y, and Z. If you're ever confused as to which one goes in which direction, there's this little handy icon here that says, hey, X is in this direction, Z is in this direction, and Y is up and down. If you are working on a 2D project, there is a very nice little toggle right here called 2D. Your project will automatically look like this 2D mode. And one thing to note, if you make a game in 2D, I often have this happen where I'm like, oh, but I put that object in there. Why are they not interacting? And it's because even though you're looking at a 2D view, the game is actually in 3D. So when you toggle this on and off, it might look like it's all on the same plane, but when you toggle this off in a 2D game, you'll be like, oh, my character sprite is like 1,000 units away. Okay, like I said, going a mile a minute, so apologize in advance. So that's my overview of what Unity looks like from here. The last two tabs that I'm going to cover are, this is my scene view. So this is what I'm looking at within whatever scene exists. A scene, if you think about it, is anytime you're playing a game, if there is a load because it's moving from one grouping of components or objects to another. So like, let's say in Skyrim, you open up a door and you walk into somebody's house. You get that loading screen because it's loading a new scene. Game view is what you see from the camera. So when you press play, this is what the camera in your game is actually looking at. Asset store is Unity's asset store. It is basically a web browser within this entire project. So honestly, if you have your Unity credentials, I just use whatever web browser I prefer instead. But it does make it handy to toss things in. So I'm just going to make this 0 and 0. And then I'm going to pull them up a little bit. There we go. So you can actually see my camera preview over here. That's what I'm looking at as I'm centering this guy. All right. So let's see. Like I mentioned earlier, so that's my intro to Unity. Next is components. What are they? So like I mentioned earlier, components are the very user-friendly version of code. So whenever you hit this little plus button, or if you go to game object, you can create something, or if I go over here, I can create something. All of those are ways that you can have Unity's objects that they've already got prefabricated for you with certain components on them. That's how you add them to your scene. Components are basically like classes in any other programming language, any other object-oriented language. So whenever you make a script for Unity, it is automatically a component, meaning that you can write one script, but you can have it on multiple objects. And if you have individual values that you need to set on each one of those objects, you can change it. So for example, on this cube, I have a box collider. Let's say that this was the C# script that I had written. If I change any of the material in any of these items here, if I change the fact that it is a trigger or isn't a trigger, if I change any of these values, it's not going to have any bearing on another cube with another box collider on it. So, having said all of that, so that's a little bit about what components are. You can add components by clicking this add component button. Unity has a bunch of components that they've already got. So they've already got physics. Note that some of these components will be different between 3D and 2D. They've got some scripts and things that you can go ahead and look through. You can also, if you have one in your project, let's see, if I create a new folder here and just do scripts. So if I had a script in here, I'm going to go ahead and create C# script. Script 001. There we go. If I wanted to add this script to any object that's in my game, I can go ahead and just drag it onto that object. But for now, I'm just going to leave it. So I've got this cube here. It's acting as my floor. See, how's my time doing? Whew, I got to move faster. So I'm just going to add a sphere here. I'm going to pull it up here so that we can see it. I want my sphere to have some gravity, so I'm just going to go ahead and add, let's see, rigid body. So rigid body means physics. Cool, I've added physics. So now if I press play, I should have a cube that is falling. Yay! All right. Now that I've done that, I think what I want to do instead, probably the easiest script to write will be, yeah, I'm just gonna add 01, and I'm just gonna make a script that when it falls into a box collider, changes color. So I'm going to create an empty object here. So an empty object is literally, it's just a transform. It's just a place in your visual space. I use this frequently if I need something like in a UI, or if I need to organize things in the hierarchy, or if, in this case, I only want a single component, which is a box collider. So if you've ever seen like Indiana Jones, and he's got the item, and he's like, oh, I gotta make sure to move this item very carefully so that, let's see, let's go ahead and copy the position of the X and Y here, or the X and Z here. And he's like, I gotta move this very carefully so that I can steal this object. That's basically what I'm gonna do. I am just making, oh no, that's why. Back and Z, that's what I want. There we go. So X should be in the right spot. Yes, and Z. Cool. And the last thing I'm going to do is say, hey, this is a trigger. All right. So now opening up this, ooh, I should have opened Visual Studio earlier. So what I was trying to say earlier, and I got a little tripped up in my words. If you enter into a space in a video game and you trigger a scene, or if you take one object and you put it into a place and it triggers something, like maybe arrows fly out at Indiana Jones, or that ball starts rolling down to hit him because he removed something. In video games, that's called on trigger enter. So I'm going to hop off on that or use that to change the material of my object and just make my sphere a red sphere. So real quick, when you open up a script for the first time, it will have start and it will have update. So for the most part, if you want something to run once at the beginning when your object first becomes enabled or when the scene first starts. You're going to want to use start. The one thing to note is that occasionally, if you have a bunch of objects that have scripts that run in this start function that all depend on each other, depending on the order in which they are rendering in your Unity scene, that might cause errors. So just be careful of that. Unity in general, you have the void start, you have void awake, and you have void on enable. All three of those functions are going to run at different times depending on the timing of the entire thing. So start runs before the first frame is updated in your game. Awake is when the object is first called. So awake comes before start. And then on enabled, you can start with an object. If I unclick it here, I'm saying that this object is not enabled. It doesn't exist until I flip it back and say it is enabled. So all of that. Update will run once per frame. Be careful loading a bunch of like really heavy math into void update, because if you have a bunch of really heavy math or heavy computational stuff that's in the void update, it will really slow your frame rate. So let's see, I'm going to want to save a I'm going to make a private renderer. Renderer. So a renderer is just a class that says it is exactly the class that renders an object in visual space. So on start, I'm going to say renderer. So if we look at the components of my sphere here, so I have my script as one component, and I want to be able to access these other components on here. So all I have to do is say, hey, get component. And get component is going to search through whatever object this is attached to and pull the first object that matches it. So in this case, I want to get the renderer. So in this case, I want to get the renderer from this object and store it. Cool. One thing to note, if you do this and you forget to put the renderer on there, it's going to throw a bunch of errors. So a bit of something that you can do for your own sake as well as the sake of your teams is that you can require that if you add this script to any object, that it must also add the renderer script. Every object has renderer on it, so it's not going to matter for this one. But let's say, for example, I needed to access the text mesh or a text value from something. I could say require component type of, and then I could say text mesh pro you good or something like that. I could say rigid body to require that I get the rigid body. Whatever I need, I can put it in there. Since I don't need that for the renderer, I'm just going to say this. I'm also not going to need the void update because instead I'm going to use that method that I mentioned earlier called on trigger enter. So on trigger enter is pretty useful for, like I mentioned, when you're passing through, when you have one object passing through another. You can also do, if you want two objects with physics with mass that are going to bump into each other, you could do on collision enter instead. If you want something to happen when an object leaves a space, you can have on trigger exit. If you want something to only happen when you have an object within a space, you can do on trigger stay. So these are really versatile things, especially for something like a game jam. So I'm gonna say, hey, on trigger enter, let's do material m is equal to renderer dot material. So all this is doing is taking the material, which is basically the color, or yeah, it could be the color, it could be a 3D whatever. It's gonna take the material from my cube and it's going to turn it into something, and it's gonna store it. So now I'm gonna say, hey, m dot color is now equal to color dot red. There we go. All right. And I'm also realizing that I've actually messed up a little bit. I think, yeah, I think that this actually has to work. I may have messed up, you guys. This might actually have to be attached to the game object instead. So, but I'm gonna fix that really quick by doing a serialized field. So what this serialized field does is that if it's private, the only thing that can access it is this class and any classes that inherit from it. But by having this serialized field, it'll show up in my inspector. So once I save this, Unity will reload it and it'll say, oh, hey, you've got this. But instead of that, I'm going to say private game object. And then I'm going to say obj dot get component render. Now why are you yelling at me? Oh, because I don't need it at all. That's right. Other dot renderer. There we go. Cool. I promise I know what I'm doing, even though it definitely doesn't seem like I do right now. Cool. So let's remove this from here and add it to here. All right, let's see if this works. Oh, right. I have to re-add physics so that it falls. Hey, there we go. Now we have an object that is actually changing color. Cool. And I think that that's actually all I have time for. So apologies for that, for it not being as clear or concise as I probably wanted. Does anybody have any last minute questions for me? Any questions? No?
I think you did a really good job, Randy.
Cool.
Thank you, Brandy.
Thank you.
Thank you.
All right. I think that the next workshop that's coming up is going to be about programming in VR.